test. So, Adam, would you please confirm if you hear? Test. Please confirm. Okay, good. No. Okay, thank you very much for continuing to support the class by your presence. So Monday and Tuesday there will be presentations, and I didn't process finalized schedule. If you can log into your Google Docs to where you made your votes, please, after your name and brackets, tell your preferences on Monday or Tuesday. So ideally, we want like first half on Monday, second and Tuesday, but it's kind of flexible because we all know what is going on. So it's not a big deal, but it's better to have things scheduled ahead of time so that we do not have surprises and missing speakers on one day and too many speakers on the other. So here is the list of the subjects, and we did cover maybe too many, more than need. Basically, we covered most of the things, but I would like. I'm going to look through the list, see what is missing, and if you have covered everything, we can just go to the next material, which was planned to be offered after the presentations. While I'm mumbling the introduction, please download MobileXterm, run it, and log into Photon server. I will give general overview, and then we'll go through practical exercises. The goal of the first part of the practical part of the course is to either build atomistic models or borrow them from the databases, so that later on we can safely explore their electronic structure. So we did several key things of building models, saving and reading, and there is one critically important thing that we didn't cover, one wishful thing, and then the rest can be made as we go through, or we can immediately jump into next portion of material. So the most important thing that we all need to get hands on is transferring files. So let me please give me a little sign if you from your other experience in your research or other activities, if you feel comfortable transferring files between computers easily, if you have no idea how to do it, or if you heard something but need a refreshment, more or less. Please show who is confident. Anyone confident transferring files? Anyone from the group of Professor Shah? Wenjen, are you happy transferring files between clusters? Transfer files. Say, show yes if you. So let me take a little interview. So how do you transfer files between different computers?
What? Sorry.
How do you transfer files between different computers?
Even use Google Drive.
What?
Google Drive.
Okay, and if you need to transfer files to or from the CCast, how do you send files to or from CCast?
CyberDuck.
What?
CyberDuck. Use an app named CyberDuck.
Okay, so, CyberDuck. Maybe you can log into your into this meeting and just show how the CyberDuck is looking like. Can you do it? Share a screen and show it to us. And I will make sure you have the admit all. Thank you, Amir. Thank you, Hemant. Thank you, Sarah, for joining. And Venjan, are you going to connect? Okay. So to those who are just connected, our goal number one for today's meeting is transferring files. And we are doing a little slow start, and then we will speed up. And just giving you heads up, please prepare. Transferring files will be not easy. It looks similar. Everyone can use Google Docs, but the specific skill that we're going to learn is at least as painful as using VI editor. So it's something not natural. And if you want to walk forward and learn something on your own, try to learn SCP command. Just read about it either in help manual or online. So Venjan, did you connect to the Zoom? Zoom. Link for this lab. Let me send the link for you. Copy. Oh, hello, Amir. Thank you for putting your camera on. So right now I've got only a positive answer from Venjan about transferring files. Is anyone who is on connection online can answer the question, how do you transfer files between local computer and remote supercomputer like a CCast? So if you have an idea,
I use WinSCP for it.
Please speak.
I use WinSCP. Do you hear me?
Oh,
Can you hear me?
Very strong.
I can hear you, Haman, but I believe Dr. Killing.
Yes, I think so.
Yeah.
No, we cannot hear your sound. Try once again. Try speaking.
Can you hear us?
Yeah, much better. So,
Okay, sounds good.
please tell how do you transfer files?
I use WinSCP.
Okay, WinSCP, very good.
Yes.
Yeah, same here.
Okay, so please open WinSCP on your computers and prepare to share screen. I'm going to show something more old-fashioned and reliable, but if you have connection to what you guys are doing every day, it could be useful. So you have several options. So Vinjen, are you ready to share screen and show your which app you are using for transferring files? Okay, so please go ahead sharing screen.
Here. Sorry.
I think yes.
Excuse me, Wenjin, if you're explaining anything, I believe I can't hear you.
I can't hear you, Wenjian, too.
Okay, yeah, many thanks. And if we want to use the same software as you do, we just need to go into Google and look for download CyberDucks. Is it free? Okay, so did you understood what Venjan instructed? Or not yet? Please show if it is clear, if it is completely non-clear, or more or less. Okay.
Can you just tell us that which software he used?
Pardon?
Can he just tell us that which software he used to transfer the files?
Used CyberDuck. Venjan, would you please type the name of the software in the chat line? Yeah, thank you, Hanman, for requesting clarification. Okay, good. Hanman, are you volunteering to share screen and show example WinSCP?
Yes.
Okay, please do.
Please allow me to share the screen.
Yes, I did.
So can you see this? Can you see my screen?
Mm-hmm.
So here, this is the interface of the WinSCP software. So on the left-hand side, I opened the folders from my desktop, and this is the Thunder Cast, and this is the Thunder Cast folder where I saved my file. So basically, what I do, so directly I just drag it and drop it here on my desktop folder. So if you see, so it is already get copied here. So if you want to copy it on the Thunder Cast, so same thing I just do, just copy it and drag it and drop it here. So in the same way, what I do the transfer of files on WinSCP.
Okay, yeah, thank you very much. Other questions to Hemant? Or it is quite clear? Amir, do you have any corrections or additional word of wisdom about transferring files with WinSCP?
No, I believe he covered everything.
Okay. Hanman, thank you very much.
Yeah.
Amir, thank you very much. You can stop sharing. So I will summarize and then go to a little bit more challenging part. So in the same way as we did with MobaXterm, so there are client software where you type in to which server you want to connect. You give your server username, type a password, and then it mounts the disk on the remote server as if it will be part of your local computer. And you operate it in the same way as you did in your file manager, drag and drop files with mouse, right? Makes sense. This is very comfortable and perfect. But there is a situation when it fails. When this approach is not as reliable. Suppose you need to connect to several remote computers. Suppose you need to transfer files between different clusters. Of course, you can connect to both remote computers through your WinSCP, bring file locally, and then put it to another computer. But typically, connection, the speed of internet between our local PCs and remote computers is on the level of everyday simple users, even if we are at the university. While data centers, big supercomputers, they are connected by high-speed data lines. And it is much more efficient to have a direct transfer of files between supercomputers. So what I'm going to tell is more universal. It will work perfectly for transferring data from supercomputer to supercomputer. And also it can be used to transfer between local computer and remote cluster. But we all should know the skill. But for practical work, sometimes you will use more user-friendly activities, as were demonstrated by Wenjan, Hanmant, and Amir. So the command that I'm going to bring in, probably, yeah, it is SCP. Let me type SCP in the chat line, and the format is as follows. You type SCP, then to download SCP host user at host path /file space and then local directory. Sometimes one just uses period. And I will give examples. It just I'm telling general idea. Now for upload from local computer, one types SCP file at local computer space, and then for the remote computer you type user host path, and then hit enter. So two scenarios: when we need to bring files to here and when we need to upload something. So under user at host, we can use like this Photon server. Under path, we can use this Scratch 001 chem blah blah blah. We are going to copy paste. And there, before we go to practical thing, I promise we carefully study. It's worse. I noticed in previous years, some of students were excellent in other subjects, but missed this thing, which slows down research progress. So it's better to get this basic skill for everyone with all details. There is a little challenge to that some people get naturally and some need to discuss additionally. Where we are downloading files to at the local computer. So we all have folders at local computer. We know how to specify folders at remote computer, but where at local computer we are connecting to. And these folders, what Vengean used another word to call them, directories, folders, and you use another word. Huh? Dictionary. Well, directory is better, but you all know folders, right? In file system. So here I'm going to do one example, and then maybe we'll do several of those. So I am going to the Photon. So there is a directory as usual, like Scratch, CHEM, my name, and I created subdirectory for this lab number 3. There are a couple of files, and they can be files created by.
Dr. Killian, can you
yes?
please share your screen?
Oh yes, I need to share screen. So sorry. Yeah, thank you so much for reminding me. Yes, absolutely correct. Thank you, Herman. So, so on the remote computer, I'm on this directory. I do have a file that I probably want to transfer here. Maybe need to get this file on local PC. So I am opening, like clicking plus to open another tab in the mobile extern. And then I did, I wanted to navigate to desktop because desktop is quite an easy place which I can easily find with a file browser. So to get to a desktop, the path can be slightly different on Mac and PC, and depending on who is user. But let me show the whole thing. So if you just open, you will arrive to, so this mobile extern allows to browse through directories on the local computer, right? But this home/mobile extern is like, who knows where it is. So I can do cd space dot, bless you, which will bring me one wrong up, cd space dot, wd, cd space dot, and then it shows a little strange things which show emulation of Linux environment on this computer. So to get back to my preferred Windows style of directories, I need to go to the SIG drive. SIG drive. Yes. And then finally, I see something that I recognize as a Windows user. I have this C drive, C, which is like primary disk on Microsoft. So CD, C. And now after I can do ls, and I recognize the C drive of the computer. So from here I can do to users. There I recognize myself. So username, and here I can go to the either like my documents or whatever I want. So I prefer desktop. So right now I'm at the desktop and it is my location. Because I'm going to do little, I wouldn't call it experiments, tests of using software, I can navigate to the desktop in a file browser as well. So users, name of user, desktop. Now, on the, so I do have two tabs. One tab that establishes remote connection to Photon server, another tab which I operate local computer. So I do have files test and new name on the Photon. Now on the in the tab that corresponds to local computer, I'm typing exactly the prescription that I was typing in the chat line of Zoom. SCP user server then colon and then the path. So of course, typing the path by over again is a big pain. So it's much preferred to just copy paste it. Paste. So scratch 001 CHEM676 2022. And then I can type the name of the file, like what was the file I want to new name. I want to copy file test and file new name. New name space period and hitting enter. Now it asks me for a password and I'm typing the same password as if I'm doing connections from mobile external. And after typing the file, it tells that file is transferred by 100%. After it, I can type ls, and you see the file named new name is here, is found here in this directory. Now, I'm going to the file browser, and you see there is a file new name. I click on it, open it with whatever is available on local computer, like Notepad, and it is exactly the file that I was creating on the remote computer. Make sense? So right now it is just a simple file, but in the future we can create files. We can go through, compute something, generate some data, and then download on local computer for further visualization. A replacement of the skill is this CyberDuck and WinSCP. But this SCP is most generic and traditional. So it will work everywhere between any Linux computers. While this mouse operated things will make only one connection. If you need to go through a chain of computers, it may fail. Okay, so
Dr. Kelly,
yes.
for copying the folder, is it the same command we are going to use?
Who is speaking?
Hanmant.
Okay. So just speak a little louder.
To copy the folder, can we use the same command?
Please, we are going to do a little exercise. Please try to copy something from your personal folder. Okay. I'm going to copy the sample of the command into the chat line, right? But we need to stop sharing before chat line. Paste. But here it takes a file from my subdirectory, Dmitry Lab 3, and then new name. Please select a file from your personal directory and bring it to a local computer. And for this little exercise, a criterion of success is to see that you can open your file in the on local computer. Make sense? Okay, I'm probably going to, I don't know if I need to share screen just in case. And yeah, here's the command. I'm going to visit sites in the class and then connect to everyone who is online to make sure that we all are on the same page. So it's a little delay to other things, but it is a critical survival skill that will pay back later on. Uh-huh. No. Can I type?
Yeah, sure.
So PWD CD, 2 dots means higher up. PWD. Yes. So if you go to SIG drive, and you have your C drive. And now you can start recognizing your system of files like users. Probably default user, right?
Yes.
Let's double check if you're in the right place. If you go into this PC, desktop, no, it has a lot of things. So yeah, in some different place. So you're not default user, you're someone else. Maybe.
Yes, 17.
Okay. And do you have a directory for this class? Let's just create one.
Yeah, sure.
You see,
Yes.
now it is empty. CD. Now you can type SCP. And then start cutting pasting things. So PWD. The file that you want to copy is nc.pdb. nc.pdb space period. Enter. So you see it here. And if you go here, okay. So one photon. Right. So maybe you want this propane molecule. Now here, let's type PWG. PWG. Computational stuff is not bad, but can you find it with your file browser? Okay, okay, good, good. And use this one. Now type scp user at path. And then we need the name of the file that you want to copy. Copy, paste, space, period. Okay, so this here. And if you go, it's already here. Okay.
I just try to look that. But I just reached that. Try to.
Okay. Can you find this directory with your file browser?
Yeah, it's in the.
Where,
I haven't made.
but where would you like to save your files?
Yeah, here.
Here, right here?
Yeah.
Okay. So would you like to create a subdirectory for the bus?
Yeah. Any.
Wait, I know there is nothing. No.
Yeah, what is it? RIZ, it is.
Okay. Web 2 maybe.
Yeah.
So maybe you want to copy. Let's see which one was the last one you created?
Yeah.
Oh, you have something about tube. No. Maybe you want to copy this.
Yeah. All right.
Okay. So I copy the path. And go here and type scp. And then we need to paste the path. And then we need to paste the name of the file. Copy, paste, space, period, and then type the password. you see the file this way, and if you go here,
It has been copied. Okay.
so just look over here. Okay. Okay. So you are in the tab, or you are logged into remote server, right? And you need to open another tab. So, and find here the place where you would like to be on this computer. So SIG drive, C, and then you recognize there should be like users. Which username do you? No, here. Where are your files? Are you default user? So local disk users. Where do you store your files? Check. Public. So there are two links, but we can try to create a directory for your class. Oh, no. Who's one over? Oh, I think this one. Do you recognize is it your files? But your files. Okay. So you see, you just go ahead. Now it is empty, right? And we can here type SCP. Now on the photon, we'll see. I think the connection is interrupted. Let's close and reconnect. So which one? So we need to copy the path. So you paste the path. Then we need to give the name of the file that you want to copy, like maybe C3. Paste. Okay, I can just type C3H. No. C3H8 propane PV. Space period. It will not work because it should be different case. Yes. So it will decline. See file is here. And we go to browser. You see it is here. We're able to practice all these things. Okay. That's great. That's great. Yeah. Did it work? Are you trying to download or upload? No, you're trying to upload, right? From this computer to the server. Okay. 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 Which file do you want to download? Like test3. So we copy the path. And it's case sensitive. If we miss anything, it may not work. So desktop, SCP. So now we want to download user server. It's better to paste because you can. So here between these two, it's not underscore, but it is slash. Test3 dot, what was it, dot XYZ. XYZ space period. Okay. My pleasure.
I guess I did. I'm just like uploading from my local back to this, so I just wanted to make sure I had that quick.
I'm going to demonstrate and then make another exercise for everyone.
For local.
Yes, for uploading. Everything works? Okay, do not worry. here. It's probably already disconnected. We need to reconnect. Which one? So which file do you want to download? Maybe polymer.xyz. Okay. So we need to copy the path. And here. I'm going to C drive. You see, you have the C. Now we recognize typical Windows system. Okay, and I can open this desktop on here, and it has nothing. Now in the command line we can make main. See, it did appear. And now here we type SCP. And now paste path. And then we need to name of the file. Polymer.xyz. Space, period. Transferred. It's here, and we can click. Do you recognize the file? Okay. Okay, now it's time to check with those who are online. So I stop sharing, and we'll ask you to connect to share screens as in the order as you appear here. So first Hanman, second Amir, third Sarah, and then Adam. Adam, sorry, I didn't mean you to be the last. It's just how names appear on my screen. So Hanman, please share screen.
So this is the local folder. Means this is the here
Okay. Okay. And minus R stands for.
I just copied the folder which is lab 3 by putting minus R. So I wanted to copy by the folder. So I tried it.
Hanman, were you able to find this folder and files in the regular file browser?
Which one?
Regular
fo-
file browser?
This one. So as per your instruction, I just searched here, and based on that,
Yeah, but do you see where it is on your local computer?
yes, yes, yes,
Can you show me that? Confirm that you can.
yes, yes. It is here.
Okay.
Yes, this one and this one, lab 3.
Okay. Excellent. Yeah. Thank you. You're done. You can stop sharing. Okay. Amir, would you please share your screen? Okay. Well, yes, you did copy something from from my subdirectory. Can you copy something from your subdirectory? Let me type something on your screen if you permit. So I'm going to use the tab Scratch 001. CD So suppose you want to copy the file gview test.xyz. Make sense? So we need to copy the path, which is different in this case. Copy. Then go to the tab on the local computer and we can either edit the record for the path or just completely paste it in new. Paste. And then we need a file gviewtest.xyz. Copy. Paste. There shouldn't be space between slash and gview. Space period. And here one types the, oh, okay, you have remembered password. Now you see the file here, and if you go into your directory in the file browser, you can see and probably recognize that it is the file that you have created based on Gaussian. Amir, do you confirm that everything works well?
Yes, thank you.
Any questions?
No, it's clear to me.
Yeah, thank you. Then you can stop sharing. Let me check if Sarah make Sarah as a co-host. Yes. So Sarah, please start sharing.
Okay, sure. Okay, so I copied Yeah, I copied this file from my directory and this file from your directory, and then
Okay, yes, I see. No, I do see the commands. Everything is excellent. Yeah,
thank you.
yeah, you can stop sharing. Adam, let me check if you have, let me make you a co-host. Yes. So Adam, please consider sharing screen. Okay, lab3.txt. And now would you please open this file in regular Windows environment file browser? Oh, it's empty. Let's do this exercise once again and transfer something non-zero. No. Right now it is on the local computer, right? Let me ask.
Yeah.
Let me ask you permission to type something on your computer, and if you provide it to me, so let's go. Right now we have on a photon.
Yep.
PWD. Let's go one rung up. Let's go to last lab and look for maybe diethylamine. Okay, let's download this file to your local computer.
Okay.
So copy this stuff and just make sure that the file is non-zero. Okay, we are going to this place, and you're uploading, and I'm just checking if you can do download. Paste. .xyz. If I mistype the name, then it will not work.
Yep. Looks good to me.
Thank you. So it downloads more diethylamine. So it is the same file, but now it is on your local computer. And if you go here, you can click.
Perfect.
And open it with whatever. So you recognize it is the same file, right?
Yep.
Okay, yeah, thank you. You can stop sharing.
Okay. Thanks.
So now I'm going to share myself. So we already spent an hour on this. If I want to upload a file, let's see which files I have. For example, I do have a file named test3, which gives the Zoom link for our meeting. Test3. I can upload this file by using the same command, but now I'm giving the name of the file as first thing, and then user server path as a second argument. So it did upload. It was uploaded, and now I'm going to the remote directory on a photon, and I do see that there is new file, more test3, it shows this link to our Zoom. So I can transmit files to and from by this painful Linux command. So I know it is it is as the same level of discomfort as using VI editor, but it is like learning ancient languages like Latin. It helps in the future. Is it okay if we skip visits for uploading? So it's basically the same thing, right? Now, what else? There is a long list, and we can try to cover several things, but let me cover, or at least start covering a subject of databases. Based on the submitted homeworks, I see that some of you are already aware of different tools for generating crystal structures or databases, but let's have something common that we discussed in the class. So here is my brief plan. Let me type, maybe I'll type it in the chat line. So I'm going to do the following thing. Inspect the database called Crystallography Open Database. So code not like a fish, but Crystallography Open Database. Inspect tube builder TubeGen. Then I'm typing it only to Hanmant. I need to type it for everyone. COD TubeGen, and then I will either in both of them or on one of them I will download or create a template file, upload it to the Photon server, and open file with molecular model that I didn't create myself, but borrowed from other people on the globe. Okay, so I will show an alternative way to get molecular models without wasting my personal effort of clicking buttons. So I will upload and visualize. Upload and visualize. And maybe if time allows, I will look over our whole list of subjects, but if everything is covered, then the next big thing after this is actual optimization. Okay, sharing screen. Okay, so I'll just do it over. I was doing a little preparation before class started. So in Google, I type COD Open Crystallography Database. So it is not the only one. There are like a few dozen open databases, and there are some commercial databases. 10 years ago, the best database was from US Navy Research Lab, but they decided to make it closed and password not for the general public. So it was really good, but now one needs some additional agreement. This COD is free. So what are those? I'm going to show quick things very quickly, but generally what it is. There is an effect of diffraction, right? When waves hit some regular structures and scatter in a certain directions. And if you have a sample, you have a source of rays, typically X-rays, and then we scan different positions, different angles, one can learn how the X-ray diffracts from this crystal lattice, and by analyzing and doing some mathematical procedures based on inverse Fourier transform, one can reconstruct the positions of each ion in the structure. So this is a bread and butter of crystallographers. So they just characterize materials. And in their area of activity, files directly borrowed from X-ray crystallography are have standard extension CIF, which is like, I don't know what is this abbreviation of it, maybe crystallography information file or something like that. Gauss view recognizes this format. So if you got CIF.CIF file, you can immediately load into Gauss view and open a model. When there are a range of chemical journals who decline to publish papers if the authors do not provide .cif files, because science should be open and all readers need to know which structure was explored. And in the supporting information for the paper, for many papers, one can find this .cif files. So basically, any crystal that was studied in the literature can be found. And if we need just to slightly modify, if you have an idea to study certain material, we can, instead of building, we can just download and then open it in Gauss view and start calculations. Make sense? So on big servers and small servers, for security, people often disable browsers. Therefore, we cannot log into CClust or Photon, open browser, and run this database. It's for security, we connect to database on our local computer, download, and then upload to the cluster. Therefore, we practice this download and upload. So it's not just a frivolous exercise to make your life harder. We need it for practical research. So we're going to browse online, download some file, and then we can bring it to Photon and open. Make sense? So there is a button search, and I think Amir does know, and anyone who has chemical background and anyone who has background in cheminformatics know what SMILES nomenclature is. Other volunteers to briefly tell? Amir, would you like to teach all of us what is SMILES? Or yeah, please try.
Oh, yeah. So my understanding is like SMILES is just a structure to, let's say it's how the computer stores the structure of a molecule. So it has some notation, notations for itself, and then you can describe the structure of the molecule into a, for example, TXT file or whatever.
Yeah, thank you. It's good enough. So if we deal with simple compounds like H2, O2, H2O, it's self-evident. But if it is a big organic molecule, there are isomers, same proportion, same amount of atoms, but different spatial structures. It can be encoded into SMILES. It is another way to represent. And some people know what they want. They type the SMILES and then get database. I'm not going to do it. There are text. So I like perovskite crystals because they are famous for efficient photovoltaics. And then I know, it's only an example, that it's composed of cesium, lead, and bromine. So it's one of the materials that was recent little revolution in material science. So, and then I just type send. So it will go over records. And then it gives several, 5 entries here. So it gives the source, so which paper cites provided this information. And it means if I go to this paper, it will also provide the crystallography structure. Now, what do we have? Like ID, actual CIF file that we may need, additional like formula, space group, cell parameter, cell volume. So the smaller the cell volume, the quicker is the calculation. So I may want to order it according to cell volume. In it's like cubic angstroms. 10 by 10 by 10 angstrom will be 1000 cubic angstroms, and it is something that software that we will learn in 1 month, WASP can easily do. So from about 1000 to like 4000 is very doable. If bigger, is hard. So the first one, it is a combination of bromine and iodine, which makes the crystal more complicated. I'm going to the next one. So only bromine, cesium, and lead. So I can click and see on the structure and even rotate it. And there is a file to download. So .cif. So I click on this file, and there should be a button to download. Or just so .cif files have very similar information as standard notations in computational chemistry, but it is a little longer, so it has additional information. So we just may want to save it. Save as desktop, and I will call it perovskite.cif. And the .cif files can be opened by Gaussian as is. They can be transformed to another formats by Babel. And they're just good thing to work with. So no, just a second. Yes, here is this perovskite, more perovskite.cif. And I want to upload this file to Photon. So I just replace, hit tab to continue, type the password. And then it should be there. So some C files may have problems, and chemical software may decline to read them. So I didn't check that this specific file will be successfully read by Gauss-View, but let me try luck. File, open, type of file, crystallographic information files. Okay, so it did read atoms, and the probably purple are gray are cesium, purple are lead, and red are bromines. It shows this cube because it is, the cell is replicating. And if I know how to do calculations with periodic structures, I can go ahead. So this procedure replaces my effort to draw structures, because if we study small molecules, if we are if you love chemistry from childhood, you probably enjoy clicking atoms. Some people hate it because it's so many chances to do something wrong. So for known structures, one can just download, and it is completely legitimate way. You may try this skill yourself right now, especially those who may have selected the subject of talking about databases. And to save time, I'm going to immediately show the next skill and then make a walk over the seats. So the second skill is to use automatic builders. So some CIF files is very general. It will work for anything. But some structures do not have affinity to crystallize. So the only those structures that naturally will assemble into repeating structures can be analyzed this way. Some structures are amorphous by their nature, but they still have repeating units, they have some symmetry. And there are classes of materials under these circumstances, and one of the examples are carbon nanotubes. Right? So, and you did practice it in the homework. So let's just explore. Some of you already practiced carbon nanotube builders from like VMD or Avogadro. There is the first and maybe, I don't know, maybe most efficient is TubeGen, which is one can download and run on a local computer or just practice it remotely. So there is a server where this code is running and one can download structures. So on the local computer, again, I'm going to the Google and type TubeGen. So TubeGen online. If one explores this website, there will be also local. So to practice this software, one needs a bit of basics on carbon nanotubes. So there is infinite number of carbon nanotubes. They differ from each other by their diameter and so-called chirality. So there are two parameters that make them thin, thick, semiconducting or metallic, and the chirality is like twist in rolling. So these properties are encoded in two numbers. Typically one writes carbon nanotube, then brackets, and then two numbers, MN. And the one, I know that some of the homeworks was showing 6.5 tube, which is experimentally most typical. The one that I was like kind of guessing that prompting to do is 11.0, which 11, first number controls diameter and second controls twist. The nanotubes where the second number equals 0 have very short periodic elementary unit cell, and they're easier to compute. Those where two numbers are different are quite challenging. So I'm selecting 11.0. Here we're doing carbon nanotubes, although one can build nanotubes of other elements. For example, in the periodic table, there are elements to left and to the right, boron and nitrogen. So in average, they have the same amount of valent electrons. Like if you have one boron, one nitrogen, and we count shared electrons, it's same as two carbons. But boro-nitrogen BN nanotubes are chemically inactive, and one uses them for making a surface of thrusters for ionic engines for maneuvering in space. And there are some other applications, but we are going to do carbon nanotubes. So Now one needs to tell cell replication count. So how many unit cells? And after this, I could generate, and it does create XYZ file, or maybe even Gaussian file. So yes, it is Gaussian input file. So it automatically creates this initial shape, and then positions of ions, type of element, and 3 Cartesian projections. So I may want to save this file, CubeGen online 11.0, but this was .com Gaussian input file. Okay, and I'm going. So I did practice generating tube, but I do not know. Maybe I made a mistake. I want to open it and see if I did something, if I did things correct. So next step would be to upload this file to server, and then try to plot it. By the way, here is a little hint. When we are downloading or uploading files, the best hint is a use of star symbol, which means like star means anything that is available into this file, or if you put star in between or after some symbols, it's like after certain symbols, we can have any combination of the rest of the symbols. For example, if I want to download or upload all files into in certain directory, instead of giving explicit name of the file, I can just use star, which means everything which you see here. Uploading. And there, let me check if this Gaussian input file was created good enough. .com. Open. Okay, so you see here is the fragment of nanotube. So it is what I would do if I need to do the homework myself. So to avoid clicking, one can download things from database, and then I can do it only with the little chemical thing. So let me make. Oh, Sarah raised hand. Yes, Sarah, please.
Professor, is this a periodic structure for Gaussian or not? Or just a molecule? Because I don't see the arrow of the periodicity.
You don't see what?
The vector of periodicity. That if it's one dimension.
So right now, I wasn't checking if there is a. Let's check.
I guess it was BBV. The function was BVE.
Yes. So it just suggests a functional, and there, you see, one can select Gaussian with PBC, and then the vector will be there. Does that answer your question?
Yeah, of course, yeah. Okay, thank you.
It has several formats. Okay, so I'm going to walk over the seats, and you can try both database and CubeGen, or select one which is most interesting for you. So let's plan to invest about 15 minutes in visiting everyone and make sure you can practice the skill. So get a structure either in database or this builder, upload it to the Photon server, and open it with Gauss view. Make sense? and you select on your own. Do you want .cif or CubeGen? Maybe for both there will be not enough time. So I will visit those who are in person in class and then online. Bigger diameter. Okay.
It's okay to.
Yeah, yeah.
do it and restart. Can I find CIF files for amorphous materials? It's a main phase in cement.
I don't know, but you can try, because people who do simulations are often pushed by editors to publish their structures.
Right. If you have a structure, molecular structure, can you guess the, for example, conductivity?
Yes, yes,
Oh, that's great.
yes. This,
If I'm able to do that, that would be great.
yes, we will do it in class. So you just practice a little patience. We'll do it in maybe like 2 months.
Oh, that's great. That's perfect.
Okay, so
So now I need to upload it, right?
great.
SCP.
You do not need to type all the things, because if you are already practicing it, if it is in the right directory, you can just type the name of the file here. If you put your file in the Okay. Wait. On the local computer, maybe you do not have Gaussian.
Oh,
You need to
right.
click here. Okay. So PWD LS. And now you have this TubeGen TXT. You may to rename it either copy or MV. So copy TubeGen TXT, TubeGen.com if it is in Gaussian format. Now GView point XC, and don't forget this ampersand, otherwise it will block your other commands. Okay, enter. Oh, maybe there is a spelling.
Oh,
I edit all the time. TubeGen.com. Oh, excellent.
Thank you.
If it logged out, then you just close and log over. Okay, and if you do not want to be logged out, you type TOP, and then it's checks the process, and then we will not log out. Type Control C to exit. Okay. Okay, so what do you do? This one or TubeGen? Did you upload them? So you don't need star here, and also Linux does not like spaces in the names. So let's do cp TubeGen online into TubeGen. If you want to make a like human word, just do underscore. Okay. Now, so thing number one, user server, there should be one slash. Okay, should log now. What? CP. Oh, and no, okay. Okay. Now it should be there. Let's check. So you see it, right? And let's upload the second stuff too. Okay. No. Which one is? Let's. Yes. Let's just restart it. 16.861.861. Okay. And
I have downloaded this file. Here it is.
did you upload it to Photon?
No,
Okay,
I
let's.
don't know how to upload it. I just save it.
Okay.
Here it is. This one is the folder. Yeah. Yeah, I think I have uploaded it. Things.
Do you see this file here?
Yeah.
No.
Okay, I got this. Look, this is what I practice after you.
Oh, here. So. What's the name of the file that you want to upload? No, where is your file?
It's in different folder.
but let's save it in this, save it in the same folder.
The folder
Save as,
we have made.
yes, the folder for the in the,
We have made the folder with the new directory.
yes. I think it was in the desktop.
The D drive.
Yes. Choose save. Quantum.
No, it's CHEM676, I guess. It's, I made this folder as a practice
Okay.
after you.
So here's your tube gem.
Okay, it's as a project.
Type the password. And let's go to the photon. So this. So is it the
Yeah,
one?
this is tube gem.
Okay. Okay.
I have a question. When I was practicing at home,
Mhm.
I just made a, I downloaded the nanotubes when I was doing the quiz assignment. I saved it in the C downloads, but it I can't open this in this folder in this.
You need
folder.
to upload it to the photon server.
Yeah,
Is
but I
it-
don't know.
If but
Before,
but now you do.
yeah.
So
Download the Gaussian.
no, you need to upload the file to the photon.
Before this, I'm saying I have to download the software for this.
Okay.
Yeah.
Okay. 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 Good. Now so here's your file, right? So browse. So we are typing this name of the file, the user server and path. Enter. Type the password. Okay, so now you see this file is here, right? Let's see. And, let's see. Okay. Make sense? Okay, yeah, very good.
I was able to do a CIF file.
Uh-huh.
I've been trying to download off of this Tubase computer, not Gaussian
Mhm. It's to open. Check Gaussian input file. Or you have PDB. And if it is PDB, you need to tell that it is PDB. The PDB files. Okay. And click on this, and then it looks like it is several models. Let's can I take? Okay. So where is the database? The tube again. Yes, I think it is here. Yeah, over. So this one looks like already Gaussian type. Let me show. So here it shows format. Gaussian, PBC, PDB. So if you select Gaussian, you can save it. Save as .com, and then let's I may mistype the password. Okay, so it's transferred. And let's look once again file. If it takes let's just do a new file. Open Gaussian input file. Tube channel line. Open. Okay. So it authors of TubeGen were knew about existence of Gaussian software, and they intentionally created output in such format that Gaussian users can immediately read it, which is not a big deal. If you look into here, it means in addition to XYZ coordinates, one just uses a couple of empty lines and keywords, which we will start to do ourselves, like starting from next week. Okay. Oh, thanks again. Okay, perfect. Yeah, thank you. TubeGen. Okay. Okay, with me. Okay, transferred. TubeGen line. Also, we need to copy it. TubeGen line into .com. So it more standard Name it. Gaussian.com. Okay. Yeah, thank you. Okay, so we are going Hemant, Amir, Sarah, and then Adam. I stop sharing. Hemant, please start sharing. Okay. Perfect. You can stop sharing. Everything is cool. Yeah, thank you. Amir. Okay, I see the tube and I see the crystal. Okay, yeah, thank you. You can stop sharing. Sarah, would you like to share screen?
Oh, so Professor, I just downloaded the file, but I need to access to Windows to be able to visualize on Gaussian view.
Okay. So while you are going to Windows, maybe Adam can share. Adam, would you like to share your screen?
I'm having some trouble.
Oh, we'll debug them together.
Okay.
Okay, so 11.0 CC. Let's let me ask your control chances. So you see line 1, 2, 3, 4, 5, 6 cell replication. So instead of 1, let's put here like 5, 6, and then just click on the generate. Okay, now click in the middle to save. Save this download, save as, and find TubeGen online. Text document is fine. Just save.
Oh.
Text document, save. Okay, now let's go to your MOBA extern into local. Yes, here, just click. And if we type, can you type ls just to check? Okay.
Hold on. There we go.
Okay, yeah, that's great. Let's return here. Yes. And now let's hit arrow up a couple of times. Well, yeah, stop. Now I'm going to, let's replace this one with your tube. Can you type tube gen or just letter T and then tab it will txt? Okay, enter. Type the password. Okay, and now let's go to Photon. Click, type ls to make sure things are here. So we have TubeGen. We need to change the TubeGen from txt to .com because it is what Gaussian loves.
Okay.
And now let's go to Gauss view if it is still open. If it is not open, let's open it. Ampersand, yep. So let's, file open. File open. Yes. And just rotate it to see it from different. Yes. Okay. Yeah, I think it's great.
Okay.
You're ready. Thank you. You can stop sharing. Sarah, would you like to share a screen and show, or maybe you need to connect from different computer? How are you going to do things?
Yeah, I've been trying, but it's not doable on Mac. So, but I downloaded a file for Crystal and Nanotube and uploaded it to my folder on Photonics.
Okay. So maybe to save time, you try to open it in Gauss view later on and just send me the screenshot.
Yes, of course, I'll do that.
Okay. Yeah. Thank you.
Thank you.
Okay. So I'm going to share screen back, and basically we are out of time. But let's see what are our where we are and what are we doing. So Linux environment, yes. Open account on CCast. Yeah, NERSC I wasn't showing yet. No one wants to show Vesta. Well, someone can select CubeGen here if someone doesn't have the subject to present. It can be added. Rasa Tuesday. Thank you for selecting build by Gauss view. No one selected bond order, but it's kind of nature, right? You just click select element and then select bond order. And whoever Hanmant or Sarah may mention it, can optimize geometry in Gauss view. In Gauss view. Oh yes, it is what we can do in the remaining few minutes. Distances, angles, copy paste fragments. Thank you, Said, for selecting it. Amir Reza for Babel, payment for editing command line, Avogadro Adam, build Amara, extern heavy, and hypercommandant. Okay, is there anyone who doesn't have, or everyone selected the subject? Looks like everyone selected subject. So let me do a last demonstration, and then I will try my best to finalize the schedule tonight or maybe early morning tomorrow. So that and also I do have examples of PowerPoint slides from previous years and recordings how similar presentations went in the past. Of course, we are not going to copy paste things, but you can use it as inspiration. So I'm willing to share this information so that it will catalyze your completion of your things. So Gaussian main window. Again, a little introduction. There are many things, but now I'm going to focus our attention on connection between Gauss view and Gaussian. So it is two pieces of software. Gauss view is only like a way to draw things and visualize. Gaussian is a software to do calculations. They are sold independently and they can work independently, but on this server, they are installed to work cooperatively. And it brings no scientific value, but it saves human patience and human time. So instead, typically, we all are going to learn how to process quantum chemistry calculations by typing commands in command line. And it is a standard professional way. But at the beginning stage, we at least want to feel a beauty of mouse operated copy paste commands. And this is done when builder and visualizer are coupled to actual problem solver. Okay. So suppose I do have this tube gen. By the way, note that each carbon connected to another carbon, not by single, not by double, but by bond order 1.5. It's one straight line and one dashed line. It's so-called as sp2 hybridization in chemistry. So Gaussian calculation setup. So this is a main thing. Job type, optimization, optimize to minimum, method, mechanics. So some of you are well-versed professionals in doing force field calculations with different software. So force field molecular mechanics is not quantum chemistry. It uses potential energy surfaces that were tabulated before based on higher level calculations or experiment. And this method is very inexpensive. So as soon as we select the job type is optimization and method is molecular mechanics, we can tell submit, save, and I want to give it a label that it is UFF optimization, just for myself, so that I am getting organized. Save and run. So this is so quick that it is already done. And I want to say, okay, show me the output of this job. So since we didn't put any terminal groups, this terminal carbons are not chemically correct. They are radicals. They are missing like hydrogens or some ligands. Therefore, they are a little bit show strange shape. But if we know for sure that this carbon should be there, if we believe that universal force field is correct, then this is optimal structure. And this structure is better than the broomstick. So while we were doing this Gaussian calculation setup and then the submit stuff, the Gauss view makes a phone call. I'm kidding. Makes a connection to the Gaussian software stored on the same server, passes on all input information, runs, asks Gaussian software to run, and then as soon as it is complete, it immediately imports the result of calculations. Right now, in the demonstration that I did show, everything was like half a second. This is not what we will see in a real life. Though, all people are hungry and ambitious for impressive results. If someone selects to do force field, then he or she selects large biomolecules with millions of atoms, and the calculation will be much longer than seconds. If someone needs nanomaterials and chemical molecules of this size of like maybe 100 atoms, then one is typically using more expensive methods. So it is quite normal that what we had as 1 second typically goes as like hour or week or a month. So it's what people are trying to do in profession. So creating a job, submitting and waiting until it is done. Right now in this job, we needed only geometry and maybe total energy. But there are many other ways to characterize materials. So Payman was asking about conductivity. So through computing, through this submitting of jobs, doing computations and analyzing them, one can extract conductivity and many other properties of materials. Of course, it is not immediately. We are done with about 1 month and we have 3 months ahead. But it is basically our avenue, our main line. And we are about to depart soon. I was just showing this demonstration so that you have general idea what we are going to do. So when we meet next few times, we will just run different type of Gaussian jobs in this expedited, simplified way. And then we will learn how to run Gaussian jobs in the command line and analyze. And then we will be done with Gaussian. We will go into different software and that one needs to run on a cluster. Okay, so I think we are ready to do presentations. Please wait for emails from me. This semester I'm teaching 2 classes and both classes have presentations on Monday. So it's a little more time for me to schedule, but I'll try to be as quick as possible to complete. So meeting is done. Thank you for stopping by. Everyone is welcome to disconnect and depart the room, but I'll stay here to answer any questions from those coming in person or online. Yeah. Looking forward to see you on Monday and Tuesday. And Adam, please exchange email with me or wait until everyone done. We need to briefly talk about research and administration if you have a minute.
Yeah, sure.
Thank you. Sarah, I did see you raised hand.
Yes, Professor, I have a question.
Please do. Please speak.
Now I see we can use Gaussian, which is molecular orbital based DFT software to simulate periodic system, and other code like VASP, which use plane wave DFT method. So if I'm gonna study the same compound using Gaussian with periodic boundary condition and using VASP, what kind of different results should I expect, or which one is more recommended and why?
So all pieces of software have the same goals. All authors of software know about achievements of each other, and at some point they should give the same answer. But there is a different programming. There is someone is more successful on another aspect. And as a matter of today, I'm going to stop recording for at least for a minute because so I'm just here to answer questions, but feel free to depart.